Okay, guys, let's go ahead and get started. This is the cylindrical tank. I'm just going to repeat myself. You guys need to know this for the exam, and so here it is right here if you're watching the video. Good luck. Okay, make sure you know it. All right, we're going to talk about the definition of extremes. All right, see if this makes sense to you. If I have a function, and I ask you where the maximum and minimum is on the function. So see if this makes sense to you. And if you guys picked up your notes here, you'll see this funky thing here, f of c less than or equal to f of x and f of c greater than or equal to f of x. And it looks very, very difficult until I tell you what we're really doing. So if I gave you this function here, and I said, where is the minimum and where is the maximum? Where would you say the minimum is on this parabola? Okay, this point right here. If I call this value c, do you agree that this value here would be called f of c, right? That's the y value of it. If you're telling me that this is a minimum, then what you're telling me is that this point, this y value of this point, not the x value, right? The y value is lower than every other point on this graph. Do you understand? Does that make sense? Okay, so that means that if this is a minimum, so if f of c is a minimum, then it is less than or equal to, and I say equal to because, maybe this thing keeps going there, there are other points that could be the same minimum value. It's going to be less or equal to every other point on the graph. Does that make sense? And that's where we get this. The minimum of f on a closed interval happens if f of c is the smallest. It's less than or equal to every other point, okay, between a and b. All right, what about a maximum? Where's the maximum on this? I just deleted some of the graph. But where's the maximum on this graph? Do you agree it'd be like right here? Right? Okay. So if I call this point C, so let me see if this will move over. No, it doesn't. Okay. So if I call this point C down here, you agree that this would be your f of c, right? And if it truly is the maximum, isn't it bigger than every other point on the graph? Or equal to, because there could be another maximum, okay? Then I would say, well, f of c is going to be bigger than equal to every other point on the graph. And that's the definition of extremes, okay? So if you see this on the AP exam, okay, that's what they're saying. Think extreme value theorem if you see that on the AP exam. All right, the other thing I want to talk about is some vocabulary for maximum and minimums. Okay, so here's our vocabulary. I want you to take a look at number 1 here, and you guys are going to do number 1 on your worksheet after we do number 1 here, okay? Right here, I want to tell you guys that this point B here, what would you call that? Yes, this is called the absolute max. Do you see from your notes, what's another word for absolute max? Do you see it? Global max, okay, or maximum. Okay, these are all synonyms, and you need to be okay with all of this vocabulary. There's another word for global max and absolute max. What is it? Yeah, it's just max. If someone asks you, what is the maximum? It's automatically the absolute max. Does that make sense? Okay. Now, there's also what's called, right here, Hallett's Peak. Okay. This is Mount Everest. Hallett's Peak is actually called what? The relative max. And if you look at your notes, there's another word for it. Do you see it? Local max. And those are all synonyms that you need to understand. All right. What do you guys think F is called? Local min. Very good. So this is a local min. It could also be called a relative min. Okay. Now, local mins and relative mins, or even local maxes and relative maxes, only occur between the endpoints. Does that make sense? So you would never call this a relative max or relative min, letter G. Okay, because it's not between the endpoints. It's just nothing that you're considering when you're talking about peaks and valleys. Does that make sense? You don't really look at the endpoints. All right, but when you're talking about maximums, you could be looking at the endpoints. So for example, do you see letter A here, down here? What could that be called? Yes, this would be called the absolute min. But I wouldn't call that the relative min. Does that make sense? Because it's not inside. Relative mins have to be like a peak or a valley. Or relative mins would be a valley. Okay. The other thing I need to tell you is look at letter D here. Now, while you might think that this is the absolute min, it is not, because it does not have a value. Okay. if I tell you what's the absolute min, you need to be able to shoot back a value to me. And since it doesn't have a value, okay, then this picture actually, we would say this picture actually does not have an absolute min. An absolute min doesn't exist on this picture. I know you guys want to say, so like if I call this 5, I know you want to say the absolute min is 4.9999999. Does that make sense? But you wouldn't be right unless you stood there and said 9 for the rest of your life. Does that make sense? Okay, so there really isn't, that's why we say there's no absolute min here. Even though you could say, well, I see it, I know you could say, you know, you could guess what it is, but we could never actually pinpoint it, okay? This right here would be neither an absolute max or absolute min, or a relative max or relative min. Nothing. It's none of that, because there's no value. If there's no value, it's none of the above. You guys good with that? Okay, look at your number 1. Go ahead and fill in all the blanks for your number 1. Okay, see if you could do it. Look at your number 1, and then as soon as you fill it in, we'll go over it together. This is on your homework.
Is this sheet our homework?
Yeah, this sheet is your homework, 1 through 7. All right, you guys ready? What's letter A? What would you call that? Absolute min. Okay, looks like you guys are still working. Almost ready? Okay, what's letter A? Absolute min. What's letter B? Local max or relative max. Great. What's letter C? Neither. Do you guys see it's neither? Because if you sit at letter C, not all the numbers to the left and right are below it, and not all the numbers to the left and right are above it. Does that make sense? So it's neither a relative max or a relative min. What's letter D? Local min or relative min. Letter E? Local max or relative max. Letter F? Local min or relative min. Can you have a sharp turn? Is it still a relative min?
Yeah.
Sure. Okay. What about letter G? Neither. Very good. All right. So you guys feel comfortable with that?
Oh, yeah.
Okay. So let's go ahead and talk about more about the extreme values here. Let's see what we have going on here. Okay. Before we get started too much, what I want to talk about is that I'm going to give you a function. I'm going to ask you to find the absolute max and the absolute min of those functions. Okay. And we're going to use derivatives to find it. And the first thing I want to talk about is that if you look at this picture here, where would you say the absolute max is? 1, 3, anywhere else? 3, 3, okay. Where would you say the absolute min is?
0, 2.
Yeah, is it 2, 0? 2, 0. Everybody good with that? Okay. And do you notice that, well, let's get the slopes of these. What's the derivative? What's the derivative here? 0. So the derivative is 0. What's the derivative here? Okay, so you agree that when you have a relative max or a relative min, or even an absolute max and absolute min, the derivative could be 0 or the derivative could be d and e. You agree with that? Okay, so that's what we're going to talk about today. That if you find all the relative maxes and mins, the derivative is always going to be 0 or d and e. So that's how we're going to find where relative max and mins are. But if you're talking about the absolute max and mins, it could happen at the peaks and valleys, but it could also happen at the endpoints. Does that make sense? I mean, the peaks and valleys could be your highest and lowest. You're not sure. But if it's not the peaks and valleys, it could happen at the endpoints too, right? And so because of that, we're going to do what's called a candidate test. And we're going to test all these numbers at peaks and valleys, at relative maxes and mins. And we're also going to test the endpoints to see where our absolute max and mins are. Now, before we get too far along, though, I want to point something out. The absolute maxes and mins are always going to occur where f prime is 0 or f prime is d and e, or it'll occur at the endpoints, okay? But just because Just because f prime is 0 doesn't mean there's a relative max or min. Okay, and let me point that one out. See this point right here? Right here. Is that a max or a min? No. But what's the slope there? 0. Do you see it? And this is called a horizontal tangent line. You guys have seen vertical tangent lines. Okay, these are horizontal tangent lines. Okay? And so whenever you have a slope of 0, meaning if the derivative is 0, you could have three things happening. Okay? You could have a relative min there. You could have a relative max there. Okay? Or you could have a horizontal tangent line. Okay? And so the way I memorized this is this. When I was teaching this a while back, it was when, well, I said Marvel in first period, but they pointed out to me Superman is not Marvel. So Superman is DC, right?
Sure.
Okay, so it was in Superman and Batman came out, and Superman was super popular. Oh, Superman, super popular. Okay, actually, I'm kind of mad at that movie because I feel like Superman should have won. But anyway, so this is what you need to know. Slopes of zeros happen at horizontal tangent lines. You agree with that? Okay, so slope of 0, superhero. Relative max, relative min, horizontal tangent line. Okay? You guys think of anything better, let me know. Okay, so here it goes. If you're thinking about when do you have a slope of 0, okay? It's slope of 0, superhero. Relative max, relative min, horizontal tangent line. Okay? And those are all the times that you have a slope of 0. Okay? But again, it doesn't mean that you have a relative max or min. The relative max and mins, just because you have f equals 0, f prime equals 0, doesn't mean there's a relative max or min. Okay? It also could be a horizontal tangent line. All right, so let's talk about, I still want to talk about the extreme value theorem. So let me go forward. And I want you guys to fill this part out. So this is in your notes. Go ahead and fill this out. We're going to talk about what the extreme value theorem says. So go ahead and fill this part out. This is what they're doing. Did I not do that right? Oh, it's 0, 1. You're right. Sorry about that. That was bad of me. Okay. Is that better? Okay. Did you guys get the same that I got? All right. This is what EBT says. EBT says you're guaranteed to have a maximum and a minimum if two things are true. And let's see what those two things are. If the endpoints exist, okay, it's a closed interval, okay, and the function is continuous, that must occur. Because do you see over here at B, the endpoint doesn't exist. Do you see how the endpoint doesn't exist here? So therefore, you don't have a maximum, okay? And over here, do you see it's not continuous, okay? And so therefore, because it wasn't continuous here, you don't have a minimum. Now, it doesn't mean that just because a function's not continuous, you won't have a minimum. I mean, you could still have minimums, okay? But the point is, if you want to guarantee that you have a maximum or minimum, if you want to guarantee it, then you must have a continuous function that has closed endpoints, okay? That the endpoints actually have a value. And that's exactly what EBT says here. So when it says what conditions are necessary to have a maximum, to guarantee that you'll have a maximum or minimum, you must have a closed interval and you must have a continuous function. And so let me show you what EBT looks like. Let's move to a lot of stuff. Let's move to here. EBT. Okay, this is what EBT looks like, and you need to understand what this says. And what it's saying is, if a function is continuous, okay, so the function is continuous, and you're on a closed interval, so you have something like 1, 5, like it's closed. There's dots at the endpoints, okay? Then you're guaranteed, okay, to have a minimum and a maximum. You're guaranteed. Okay, that's what it's saying. And we already talked about it. That's totally true. So you have any function, as long as it's continuous. You give me endpoints, okay, 1 and 5, okay? That function, this part of this function that you're looking at, for sure, I can tell you the maximum, which is going to be this point, and I can tell you the minimum, which will be this point. Does that make sense? You're guaranteed. That's what EBT says. Now, EBT gets confused with IBT, all right? And you guys know IBT, so let's compare the two. What's the difference between EBT and IBT? IBT says if the function is continuous, oh, it's the same, right? The function is continuous. IBT says if the function is continuous on a closed interval, oh, same thing. Okay, so it's not too bad. They're both exactly the same, okay? But EBT deviates from that. It says if that's true, you always have an absolute max and an absolute min, okay? And IBT says for that same function, if it's true, then f attains what? Every value between f of a and f of b. Do you remember that? And that's how they differ. So they don't differ by much, okay? It's just the conclusion that they differ. And what we're going to do today is I'm going to give you a function, and you're going to pretend like you don't know how to graph that function. Okay, I'm going to give you a function, and the function can have peaks and valleys and whatnot. Okay, and I'm going to say what's the absolute max and absolute min on that function. So what you're going to do is you're going to go through and you're going to find all the peaks and valleys. Okay, and it turns out that all the peaks and valleys happen when f prime of x is equal to 0 or what? D and E, right? Because could a peak happen at a sharp turn? Yes. Once you get all of those points, you're going to say, you know what? Absolute maxes and mins, they could actually happen at endpoints too. So you're also going to get the endpoints, okay? And then what you're going to do is you're going to find the y value of every single one of these points, and you're going to tell me where the maximum is or where the minimum is. All right? Let's look at number 1 on your notes. It'll be way clearer when we do it. Okay, so let's go to, I guess, you guys need to know this definition. You need to know the definition of a critical point or a critical number. It is when you set f prime equal to 0 or you set f prime equal to d and e, that x value that occurs at, that is called a critical point. Okay, and so we're about to do it. It'll make sense in a while, but you need to know that for the formula quiz. So let's go ahead and do a problem and things will make more sense. Look at number 1, guys. We've got the function 3x squared minus 24x minus 1 on this interval from -1 to 5. Okay, and the question is find the absolute extrema. Extrema is just a fancy word for extremes. Find the extremes. Find the maximum and find the minimum. The first thing we're going to do is we're going to take the derivative of this. Okay, so the derivative is 6x minus 24. If I want to know where all the relative max and mins are, remember relative max and mins don't take into account the endpoints. If I want to know what they all are, what I'll do is I'll set this equal to 0. Okay, or I'll set this equal to d and e. Okay, and guys, when you set something equal to d and e, you're just setting it equal to 1 over 0. You can also use 2 over 0, 5 over 0. If you're feeling especially patriotic, you know, maybe, I don't know, 212 over 0. Okay, but anything over 0. All right, and then you solve, and whatever x is equal to, those are your critical points. It's when f prime of x is equal to 0 or f prime of x is equal to d and e. Okay, so when I solve here, do you see I get x equals 4? When I solve here, you know what, let me just get this all over 1. Okay, if I have a fraction on the right, a left, one fraction on the left, one fraction on the right, and an equal sign in the middle, what can I do? Cross multiply. So when I cross multiply this, I get 1 equals 0. Well, that's so messed up, okay? So actually what happens here is you get no critical points, okay? But over here, you get a critical point of 4. You guys see that? So I have one critical point, which is 4. And what you do is you put this in what's called a candidates test. And you must show me the candidates test on your test. Okay, you must show it to me. The reason is because AP requires a candidates test as a justification. Okay, so sometimes when they say justify it, your candidates test is your justification. All right, what you do is you put in your endpoints into your candidates test because you have to test your endpoints. These are the numbers we have to test where there might be an absolute max or an absolute min. Okay, so the endpoints is 1. And then you put your critical points in. But what I want to encourage you to do, though you don't have to, is put them in order. So wherever your critical point is, if it goes between your endpoints, then put it between your endpoints. If I got a critical point that's way outside of my interval, so let's say I got a critical point of 10, if I put it in order, what I will see is that I can ignore the 10. Why can I ignore the 10? Because the question is just find the max and mins between -1 and 5, right? If there's a hump or a valley at 10, I don't really care, okay, because it's outside of what I'm looking at. Then the next thing you do is plug in. Find all of your F values. Now, this is very important. This is what I do wrong, and this is what students do wrong too. When you plug in for your F values, please do not use this function. What would happen if I use this function? What am I finding if I use this function? I'm going to find the slope. And guys, what you're going to find out is the slope is going to be 0 or DNE. Why? Because you set it equal to 0 or DNE. Okay? So it's not going to be plug into this function. You're going to plug into this function, right? Because that's what f of x is. All right. So let's plug into this function. So what I get is 3 times 1 plus 24 minus 1, and that gives me 26. Okay? Then you're going to plug in 4. Actually, you can't have a calculator on your test, but I'm your teacher, so I'm going to use a calculator. Okay, so let me get out of this mode. Okay, and then you put in a 4, so that's going to be 3 times 16 minus 24 times 4 minus 1. And what is that equal to? Negative 49, so this is negative 49. And when I plug in 5, what do I get? So it'll be 3 times 25. And guys, you can use a calculator for this part on your homework. I wouldn't suggest using a calculator for any other part, because I assume you can do this on your test. Might be a hopeful assumption. Okay, but you'll get the y values, and for sure on your test, if you have a problem like this, it wouldn't be more than 1 or 2. Does that make sense? Because this takes a while. Okay, and then you just choose the highest and lowest numbers. Does that make sense? That's going to be your absolute max or absolute min. Where is the lowest number here? Negative 49. So what you'll tell me is the absolute min is at 4 comma negative 49. Okay, where is the absolute max? Negative 126. So what you'll tell me is the absolute max is at negative 126. Now you have to be careful. When they ask you for the absolute max and min, they're at these points. You guys good with that? But guys, if they ask you for the absolute max value, what would that answer be? 26. Do you guys see that? Okay, and that is a trick that they ask you on the AP test. And since they trick you on the AP test, I thought I would try to trick you as well. Okay, so make sure you understand when I ask you for the absolute max value or the absolute max min value, you give me back the y value. Does that make sense? And of course, on the multiple choice, all the x values will be there too. Okay, just so I'm hoping that you'll get it wrong. Okay, but you guys know now, right, not to choose the x value.
So if we were to save time, would we not just plug in the D&E one?
Yeah, but how would you know if it's D&E or not?
Whenever we...
No, you have to plug in the D&E one.
But it's always going to be no critical.
Oh, it's not always going to be no critical point. Let's go to letter C. No, it's not always going to be a critical point. Go to letter C and I'll show you why. Okay. Let's skip forward, guys, and let's go to letter C, example C, and let's do this together. It's you'll get critical points for the D&E whenever you have fractions, and you'll see that this one has fractions.
Oh,
yeah.
I get it.
You got it? Okay, so let's do this one. This is a good one to do. All right. If we do this problem, okay, what we're going to do first is we're going to take the derivative. So go ahead and take the derivative. Okay. Now, like I said, guys, if you're on your test and you have no idea what to do, just take the derivative. Okay, you're going to get some partial credit. Just take the derivative. Okay? All right. Or you can hope for some partial credit. All right. Once I take the derivative to find the critical points, to find where there are possible some relative max and relative mins, what I do is I take this derivative, but be careful. Do you see that this derivative actually is a fraction? Okay? So it's this is equal to 0, or this is equal to what, guys? D&E. Guys, this is f prime of x is equal to 0, and this is f prime of x is equal to D&E. That's how you find your critical points. When you find your x is going to be your critical point. You have to set it equal to 0 or set it equal to 212 over 0. Okay? Over here, how can I solve for x here? This one's not too bad. This one's pretty bad, but this one's not too bad. How can I solve for x? Are you guys okay with adding 2 to both sides? Do you see something beautiful happens when I add 2 to both sides? What happens? You can cross multiply. Why can I cross multiply? Because I have one fraction on the left, one fraction on the right, and an equal sign in the middle. Make sure you understand. That is the only time that you can cross multiply. Okay? When I cross multiply here, what I get is 2 times x to the 1/3 is equal to 2. Are you guys okay with dividing by 2 on both sides? Okay. Now this is really difficult to understand what x is, but if you rewrite this, because what is x to the 1/3 really? Cube root. If I rewrite this, then what is x equal to? Is it equal to -1? Is -1 times -1 times -1 equal to 1? No. Okay, it's only equal to 1. All right, so therefore, guys, I know one critical point is x equals 1. Now make sure you understand, I'm not saying that x is equal to 1. I'm saying that x equals 1 is one critical point. Okay, let's go over here and find another critical point. Remember, critical points are wherever f prime is equal to 0 or f prime is d and e. Okay, the unfortunate thing about this problem is if I add 2 to this, 1 over 0 plus 2 does not help me solve for x. Okay, and so does anyone have any ideas on how you would solve something like this? Common denominator. Those are beautiful words. All right, what you need to do is get a common denominator, because then you can make this one fraction, right? And if you have one fraction on the left and one fraction on the right, what can you do? Cross multiply, right? So let's get a common denominator. This one is x to the 1/3. It's already there. Okay. If I make this one x to the 1/3, what does this become? Exactly. You guys good? So this becomes equals 1 over 0. Now, why did I try to get a common denominator? Because common denominators allow me to combine this into one fraction. Okay, so you got to get good at these fractions. Okay, the nice thing about combining these into one fraction is when I cross multiply here, look what I get. X to the 1/3 is equal to, this is a terrible thing, but all you do is you multiply this terrible thing by what? 0, which is not a terrible thing. Okay, unless it's $0. That's a terrible thing. Okay, so x to 1/3 equals 0. So guys, I don't know how to solve that, but I certainly can solve this. What is x equal to? 0. So now I have 2 critical points. One critical point is 0, and another critical point is 1. So what I do is I go put this into my candidates test. Okay, in my candidates test, I put 2 things. What are the 2 things I put in? Do you remember? Your endpoints and your critical points, and try to put them in order. So that means my 0 is between -1 and 8, and so is my 1. But guys, be careful. They're not always in between, okay? A lot of times they are, but if it were outside of my endpoints, remember just to disregard it, okay? If we had time for example B is one where you would disregard one of your critical points. Okay, now what I'm going to do here is plug it into this f of x, and I'm going to show you, if you have your calculator, you can do this a little bit more easily. And again, guys, you're not going to have your calculator for the test, so you won't have a problem this terrible, okay? But on your test, I'm sorry, not on your test, on your homework, if you want to plug it in using a table, you can. And some of the AP questions that are tougher, you will get to do this with a table, with a calculator. So let me show you how to do it. You set your y equals in. You guys good with that? Okay, there's an easier way to do this. You ready? If you go to second table set, okay, change your auto to ask. You guys have done this before, right? Change your independent auto, change it to ask, hit enter. Then hit second table, and let me delete this because I have this from previous periods. So let me go ahead and delete that. Okay, then you just copy this graph in. Does that make sense? And then you just copy over your answer. So in this graph, I have -1, enter, 0, enter, 1, enter, and 8, enter. Okay, and those answers I would just plug in over here. 6, 1, 2, -3. You guys good with that? Okay, now I've made this candidates test. You guys tell me, what's my absolute max? Here's the candidates. -1/6. So you'll tell me absolute max actually, I would say at, but I guess you don't really have to say at -1/6. What's your absolute min? 8, -3. Okay, and sometimes a lot of times I'll circle my numbers here just so that I pull the right numbers correctly over here. Any questions on this? Not too terrible, right? Okay, you just need to take the derivative and be able to plug in. Once again, be careful. Don't put f prime here. Put f. I want to talk to you about your homework on number 7. Can you take a look at number 7, please? Or actually, number 6. Let's take a look at number 6 first. Number 6 on your homework, it says to find the derivative of the absolute value of this. You can do this. It's just not super easy to find the derivative. Let me just write this for you. Those of you who want to do it, I'm just going to tell you I'm not going to do it this way. But if you want to, for fun, if you square this and square root it, it's the same as the absolute value. Okay, so you can kind of trick it, do this, and do a chain rule, and you can do that. Okay, but I'm not going to do it. I'm going to leave that for you to go home, go into a closet, and sit down by yourself and figure that out. There's an easier way to do this. Okay, the easy way to do this is to graph this. Okay, if you graph y equals 2x minus 6, what does that look like? Where's the y-intercept? Okay, you good with that? Where's the x-intercept? The y-intercept is when I set x equal to 0, right? So the y-intercept is negative 6. What's the x-intercept when I set what? Y equals 0, right? This is the y-intercept. The x-intercept is when you set y equal to 0. So what's x equal to? 3. So guys, this is 3. Okay, so I've got a slope of 2. Everybody good with that? Okay, that's y equals 2x minus 6. What do I want, though? The absolute value of that. Absolute value makes every negative number positive, right? So all it means is that if this were, and I don't know, if this were negative 1, now it's positive 1. Does that make sense? If this were negative 5, now it's positive 5. If this is negative 6, what is it now? Positive 6. So this new function here, it's your v, okay? That's going to be your graph of this. Does that make sense? Okay? And then what I'm going to do is I need my absolute maxes and mins. Well, for sure, this is an absolute min, right? And you can figure out what that is. Okay? Actually, I shouldn't say. Oh, yeah, it is absolute min. How do I find my absolute max? Well, there's a number here at negative 1. What are your endpoints? 5. Okay, so go over here to 5. Figure out what those numbers are. Does that make sense? Choose the highest one, and that's going to be your absolute max. Okay, so this one's a little bit easier to do with a graph. Okay, but you do need a candidates test on this, so I showed you how to do it, but you do need to put your negative 1, your 3, and your 5 into a candidates test for the justification. That's showing your work. All right, on number 5, I know you guys, when you guys see the trig functions that you shut down, okay, but I need to tell you, you guys know how to do this. What's the derivative of sine x? Cosine x. What's the derivative of cosine x? Negative sine x. So this derivative is going to be cosine x plus sine x. You guys good with that? And you do everything the same way. You just need to know your unit circle. Okay, you do everything the same way. We have some time, so I want to talk about number 9. Guys, oh no, not 9. 7, number 7. Okay, on number 7, you see they give you the position function. Okay, what do they ask you to maximize or minimize? The velocity. Guys, they didn't ask you to tell me the maximum minimum position. They asked you to tell me the maximum minimum what? Velocity. So guys, they gave you the position function so that you could find the velocity function. Okay, you're not going to use the position function at all, except to find the velocity function. Once you find the velocity function, cross out the position function and work with it. Does that make sense? Otherwise, you're going to be working with the wrong functions. Everybody understand what I'm saying? If I ask you to maximize velocity, don't maximize position. Okay? If I ask you to maximize f of x, you take the derivative of f of x, but then in your candidates test, you don't put the derivative, you put that f of x back. Okay? So let me just explain this to make sure you understand. You have your position function. Take the derivative of that and get your velocity function. Okay? Find out what that is. Okay? What am I asking you to maximize or minimize? Your position or velocity. So when you do your candidates test, okay, this should be velocity over here. Okay? Students are going to put position over here, but that's not what I asked you to maximize or minimize. If you maximize or minimize this velocity, remember this velocity now is going to be like your f of x. Okay? So do you see you have to take the derivative one more time, right, to get your critical points? Okay, so hopefully that will help you on number 7. I don't want to tell you everything because then I'll just end up doing it. Okay, which I know you want me to do. Okay, any questions on your homework? You guys feeling good? Okay, I think you're good to go. Make it a great day, guys.